All right, so this is 8.5 continued. Don't let the 5.6 fool you. It's 8.5. And, but I'm reviewing this because, as I think you know, probably since second grade, math builds on itself. You know, you can't subtract without knowing how to add. You can't divide without knowing how to multiply. And you can't really proceed in section 8.5 without recalling how to factor. So let me pretend we don't know the answer to this problem. All right. And what do they want us to do? Well, they want us to factor this. So how do we factor something like this? All right, so basically to factor it, as the problem suggests, you want to find the zeros. And finding the first zero is usually a big deal. So, and the first zero everyone wants to check is 1. You know, what about 1? Does that work? Well, let's see. Would it make it 0? If I put in a 1, the positives would be 1, 6, and 28. And the negatives would be 11 and 24. I don't know if that actually adds up to 0 just by calling it out, but that's the point. I don't know. If it had been, you know, all positives and no negative, obviously the f of 1 wouldn't equal 0. So let's do it. F of 1 equals 1 to the 4th plus 6 times 1 cubed minus 11 times 1 squared minus 24 times 1 plus 28. And like I said, the positives are 1, 6, and 28, and the negatives are 11 and 24. And I have 35 here, and I have 35 here. 35 minus 35, that's 0. Remember, I say bingo whenever I find a 0. So what that means to us is I want to, I need more space here. All right. I want to use synthetic division with a 1. Which I could have done instead of the f of 1, but I always think this is a synthetic division, is a little more work. Now we already know what's going to happen. I'm going to get a 0 for the remainder because f of 0 agrees with that point right there. But bring down the 1, multiply by 1, I get 7, multiply by 1, I still get 7, still get 7. $28, and of course 28 plus 28 is 0. But what's the point of that? The point is, I know that I have x minus 1, but I also have x cubed plus 7x squared minus 4x minus 28, which needs to be factored. But this can be factored by, not by hunting for factors, right? But by factoring out x squared, I get x plus 7. This is called factor by grouping, and it's a big player in Algebra 1. I'm going to get x plus 7 times this x squared, this 4, and each of those can factor. Meaning this can factor with difference of squares. So I found how to factor it, and hopefully we recall how to factor something like this. The factors are what I'm subtracting from x. So 1, 1, keep on going off the page, 1, negative 7, positive 2, and negative 2. So those are the factors. In other words, if I set each of those equal to 0, what would I get? All right, so it was just a timely review of factoring, kind of like if we were going to do division of numbers. We'd review the multiplication table or something. But I needed that in this. So I wrote a few things from the last, when I was talking about this problem earlier. This is not factored. We have to factor it. Now, this one factors without synthetic division, and I didn't even need what was it? Factor by grouping. It factors. Keep in mind, we don't know these answers already. We just have the structure of A over the first factor, x, B over, well, the second factor, x plus 2. These factors could be in any order, but C over the next factor. So when I say these could be any order, in any order, there's no way that the question could just ask, what's A? Because you might have put A over x plus x minus 3. They have to ask the whole part, right? Because the order is up to you. There really is no agreement as to how to order parentheses in a factoring problem. But once you get it factored, you have this. Now, keep in mind, this I have to visualize this as being factored. I mean, it's not optional. I need my factored side. Here equals all of this. I want to clear the fractions, so I clear the fractions by multiplying by x, x minus 2, or rather x plus 2, x minus 3. Multiply by those things, and I'll multiply everything by that. Let's write it all out. It's minus. All right, so I'm going to multiply everything by that, and it's just nicer to do it when this is factored because you kind of see the complete cancellation. So understand this entire denominator is going to cancel. I'll get 14x plus 18. What's going to happen here is the x will cancel. X plus 2, x minus 3. Let me write it here because I'm going to run out of space. If I go this way. Distributing here, the x plus 2 is going to cancel, so I'll have b x, x minus 3, and the x minus 3 is going to cancel, so I have c x, x plus 2. All right, so that's what each individual term gives me when I clear the fractions. So to put it together, it's 14x plus 18 equals, let's write this out so they have the space. X squared minus x minus 6. This is b times x squared minus 3x, and this is c times x squared plus 2x. And the reason why I wanted to write that out is, you know what I want to do. I want to collect all the terms. So it's a x squared minus ax minus 6a. I'm just distributing the a. I'll distribute the, continue working down here. Distribute the b. I have bx squared minus 3bx. and then distribute the c, I have cx squared plus 2cx. So putting all of that together, I have 14x plus 18 on this side. And what's my x squared going to be? It's going to be x squared a plus b plus c. And then my x's are going to be, let's write it here, all of those terms, a minus 3b plus 2c, and my constant term is just minus 6a. So normally I would say, well, let me definitely set up a my system. I'm not sure that I would need it in this particular problem. I would need this system, but I just want you to understand where I'm looking. The reason why I say that is I'm definitely going to use other methods as well, but this, like, I could use the forbidden x values method, but let's do it. 0x squared, just so you see where I'm looking. So 0 is the coefficient for x squared on the left, and a plus b plus c is the coefficient on the right. So my system, the x squared coefficients are going to be a plus b plus c equals 0. The x coefficients are going to be a minus 3b plus 2c is equal to this 14 right here, because that's the coefficient of x on the left-hand side. And this is very nice. The x to the 0, meaning degree 0, on the left it's, on the right it's minus 6a, and on the left it's 18. So I could start using the forbidden values, but don't really need to. I can just go ahead and solve this, divide both sides by -6, and I get a is equal to -3. So that's kind of just fell in our lap, but we found that. Now, if we didn't find that, I still think there's value in putting in a forbidden value. What I never wrote down was the line that's useful for forbidden values, because I started writing things vertically. So let me do this. What would happen if I wrote in the most traditional manner what it would look like to clear fractions? I'm going to do that. Basically, I'm going to get a big long thing with all of this in it, but long when I say it's going to be one term. All right, so I gotta slide my tablet so we can see what me writing down here. It's 14x plus 18 equals a parentheses x plus 2, x minus 3, plus bx, x minus 3. That's it. Hold on. Plus cx, x plus 2. So this is what I get when I immediately clear fractions. Since I was interested in taking that somewhere else at the moment when I wrote this all down, I never did write this down. All right. So what were my forbidden values? What would have caused division by 0? In other words, what were the zeros of the polynomial? Well, they were 0, -2, and 3. Anything that would cause any of the previous denominators to be 0 would be what I'm calling forbidden values. So I could put in 0, but a little 0 would just retread. Well, let's do it. If I let x equal 0, I think I'm going to find something I already found. If I let x equal 0, this would cancel. I just get 18. Nothing would cancel here, so I'd have a times 0 plus 2 is 2, and negative 3. But I'd have b times, well, 0 times negative 3, and I have c times 0 times 2. Obviously, those are zeros, and as I predicted, I have the exact same equation that I got earlier using coefficients. So 0 just kind of went over the same numbers. Okay, no harm done though. Confirmed that a is equal to negative 3. Let's pick another one. Let's let x equal 3. Now if x equals 3, I'm going to get, it's going to be a little bit of work here. 14 times 3 plus 18 equals, well, the a is going to drop out of this because 3 rather plus 2 times 3 minus 3, there's my 0. So a drops out. B is, sorry, it's going to be 3 times 3 minus 3. B is going to drop out. The only one that's going to survive is C. I put a 3 in for both of those x's. It's going to be 3 times 15. So what do I have? 42 plus 18 equals 15c. $60 equals 15c. Divided by 15, I get c equals 4. So now, boy, I have a lot of choices. I know A and I know C. I have a very easy equation relating A, B, and C. But my other choice is to use the forbidden value I haven't used yet. Let's do both. All right, how do I find C? One way to do it would be to recopy this with our substituted values. Remember, B was, or A was negative 3. I think I was saying find C. We know C, it's 4. Equals 0. So we just want to figure out what B would have to be. B plus 1 equals 0. I get B equals negative 1. Now let's confirm that. And that might help me confirm my answer here. And when I say confirm it, what's the other way to find B? Normally we don't know this in advance, but each forbidden value is going to reveal a different letter, at least most of the times. So the other method that will most likely reveal B is to let x equal negative 2. So if x is negative 2, we see it. It's just off the screen. Okay. I'm substituting the red equation here. It's 14 times negative 2 plus 18 equals, well, the a is going to drop out. It's a 0 times negative 2. It's going to be negative 5. The negative 5 is not important. That's 0. If I put in negative 2 here, it's going to be b times negative 2 times negative 5. So notice that didn't drop out. But c is going to be c times, well, negative 2 times 0. Right? So plugging in a negative 2 is going to make two of the terms drop out completely. And what is it going to give me? Well, this is going to be negative 28 plus 18 equals negative 10b. Or negative 10 equals negative 10b. Divide both sides by negative 10, I'm going to get b equals 1. So that does agree with the what I got here. Actually, I got a negative one there. Oh, I see it. Okay, so nice to catch an error in before it gets too far. Negative 2 times negative 5 is positive 10. So when I divide both sides here, I will get, let me write it out. Not that that's a very big calculation for most of us, but if I have 10b equals negative 10, I have b equals negative 10 over 10. So it is negative 1. All right, so caught a mistake in real time. All right. Going back to the original problem then, what is A, B, and C, at least what I called A, B, and C? Well, A, negative 3, B, negative 1, and C was 4, and that's exactly what we were looking for. So that is a full example that required a little bit more than a typical problem like this. The little bit more was you had to factor it, but at this level, being asked to factor something like this should be something you're ready to do if you have to do it. All right. I think I'll do one more, I don't know, maybe example, but look at the author's examples, look at some of the other examples of this, and you're really going to have to get a feel for whether you're going to want to, solve the system of equations in its more traditional manner, like by back substituting values, or to take advantage of this forbidden zeros method. Actually, I've been saying all along that there's going to be 3 videos, and this is the 3rd one, but I think there's going to be a 4th. So now that I think about some of the other things I want to say about this. So yeah, this is getting kind of long, but that's why it's a homework all by itself, section 8.5, part 3.